In this video, we will find the singular points of the function fz is equal to 1 by z square times z square minus 1. The singularities of this function fz are given by equating the denominator 0, that is z square times z square minus 1 is equal to 0. Factoring, we have z square times z minus 1 times z plus 1 is equal to 0. Therefore, z is equal to 0, 1 and minus 1. Therefore, these are the points of singularities of this function fz. Now we have to discuss the nature of these singularities. Now look that the limit of this function fz as z tends to 0 is infinity. Similarly, we have limit z tends to 1, fz is also infinity, and again limit z tends to negative 1, f of z is equal to infinity. Therefore, all these points 0, 1, minus 1 are poles of this function. Now we will find the residues at these poles. Before doing this, we have to find the order of these poles. See that 0 is a pole of order 2, 1 is a pole of order 1, and minus 1 is a pole of order 1. Now the residue of fz as z is equal to 0 is given by limit z tends to 0. In this case, we will write this fz as 1 by z square minus 1 divided by z square. We will treat this function as phi of z. Now by the formula of residue, this will be equal to limit z tends to 0, m minus 1 at derivative of this function phi divided by m minus 1 factorial. Now see that m is equal to 2 for the pole z is equal to 0. Therefore, it will be equal to limit z tends to 0, phi prime z first order derivative of phi divided by 1 factorial, which is 1. Now putting the value of phi z, this will be equal to limit z tends to 0, the first order derivative of this function phi z, that is d dz of 1 by z square minus 1. Now if we compute this derivative, it will be equal to limit z tends to 0 minus 2z divided by z square minus 1 whole square. Now put the value of z is equal to 0, we will get a 0. Therefore, the residue of fz at z is equal to 0 is equal to 0. Next, we will find the residue of fz as z is equal to 1. By definition, it will be equal to limit z tends to 1. In this case, we will write fz as 1 by z square times z plus 1 divided by z minus 1. The factor corresponding to this singular point 1 will appear in the bottom, and in this case we will treat this function as phi z, and here we will have m minus 1 at derivative of phi divided by m minus 1 factorial, and we know that z is equal to 1 is a pole of order 1, that is m is equal to 1. So it will be 0 derivative of phi z, which means it will be the function phi z itself, and 1 minus 1, that is 0 factorial, is equal to 1. Now put the value of this function phi z, which is 1 by z square times z plus 1. Now put the value of z, which is 1, we will have 1 divided by 1 square times 1 plus 1, which is equal to 1 over 2. So 1 by 2 is the residue of fz at z is equal to 1. In a similar way, a residue of fz as z is equal to minus 1 will be equal to limit z tends to minus 1 phi z. But in this case, phi z will be equal to 1 by z square times z minus 1, because z plus 1 will appear in the bottom. That is why we will have this function. Now put the value of z is equal to minus 1. This limit will be equal to 1 divided by minus 1 whole square times minus 1 minus 1, which is equal to minus 1 by 2. This completes our solution and this is our final answer. Thank you for watching. Please like, share and comment on the video. Also do subscribe the channel.